In this lecture, we'll find the relation between permutations and combinations, and also find a formula for combinations which will make it easier for us to compute answers to questions regarding combinations. So this theorem which we'll look at is exactly doing that. The theorem states that the permutations of n objects taken r at a time is same as combinations of n objects taken r at a time multiplied by r factorial, and where r lies between 0 and less than equal to n, and from there it follows that n choose r, or the combinations are equal to n factorial divided by r factorial and n minus r factorial. Before going into the proof for the general case of n objects, I'll look at the special case which we had already covered. So as part of the proof, I will just go through that. So we had these three tennis players, right? Before we had three tennis players, I called them with their first names Nadal, Federer, and Djokovic, N, F, and D. And we were trying to form a doubles team, right? A doubles team, which is same as 3C2. So ways to form a doubles team. Ways to make a doubles team is equal to 3 choosing 2 at a time, right? So we have to make 2 selections out of these 3. So there were only 3 ways to make such a selection. You had Nadal and Federer, Federer and Djokovic, and Djokovic and Nadal, right? These were the 3 selections, because this we had seen that this is equal to 3. So what happens is that then each of them actually can be arranged, right? So this arrangement of 2 objects taken 2 at a time, that is how much? That is 2p2, right? So you have this as 2p2 or 2 factorial. So that is 2 factorial ways you can arrange NF, and 2 factorial is 2. Similarly, you can arrange these 2 objects taken 2 at a time in 2p2 ways, right? That is permutations of 2 objects taken 2 at a time. And this also will be 2 factorial. And Dn again will be, you can arrange in 2 factorial ways or 2 ways, right? So in this case, it is, if you see, there are 6 permutations, right? What is the number of permutations you have? 3p2, or 6 possible arrangements of 3 objects taken 2 at a time, and these are equal to 6, right? Because 6 is equal to 3c2 into 2 factorial, right? There are 3 C2 ways in which selections can happen, and each of them can happen, each of the selections can be arranged in 2 factorial ways. So that is basically proved for the special case of n equal to 3 and r equal to 2. So we'll just look at the general case now, which will be easier to understand. Taking the general case, say I have n different objects, or n distinct objects, and I call them A2, A3, and n different objects, and I want to select R objects. So I can select R objects in many ways, right? And that one of those selections is, say, taking the first R objects. I just take the objects between A1 and AR. So this is one selection. So looking at this particular selection, in how many ways can you rearrange these selections? How many arrangements can you make if we already know that we picked objects from A1 to AR? That would be same as RPR, right? permutations of R objects taken R at a time. And this is same as R factorial. So you should always know that permutations of n objects taken n at a time is n factorial, so here it's R factorial. So these are all arrangements where I am just reordering or shuffling the order of these R objects. I can get R in the beginning or whatever, like that, right? So we have R factorial ways for each selection. This is one selection, and you can select R objects from these n objects in different ways, right? Again, you can just select, say, objects all from A2 to AR plus 1, right? And then you can arrange each of them also. You can arrange each of them like before in R factorial ways, like explained before. So these are all the possible arrangements you can have, shuffling the orders, all the arrangements. Obviously, I cannot write all of them, but I'm just trying to give you some kind of idea about what it will be. So this is one selection, this is two selections, and then there will be more selections where maybe you select AR first, like say you only select objects between A3 and AR plus 2 and so on. So this one will be the third selection and so on. So in this also you will be able to arrange in R factorial ways, right? So what is this? So all these arrangements, if you look at the rows and columns, they are same as permutations. The number of permutations, so number of permutations of n objects taken R at a time is same as number of rows into number of columns, right? So these are the rows 1, 2, 3 and so on. These are the number of rows, and how many columns do you have? R factorial, right? So this is the number of rows you have are the selections. So I can also call the number of rows as number of ways to select R objects out of n, and number of columns are number of ways to arrange R objects. Okay, so this, by definition, we know that number of ways to select R objects out of n is exactly n choose R, and the number of ways to arrange those R objects, like we saw here, is R factorial or RPR, which is R factorial. So this will be R factorial, right? So we have already proved this now. So just try to understand permutations. So permutations, I can call the permutations are as the product of two things. First, you can actually select R objects out of n, and then you can arrange them. So permutation can be looked at as a combination of two things. This is very clear here, right? I made a selection like here. I selected it and then I do the arrangements. Selected it and then I did the arrangement. Selected it and then I did the arrangement. So this is one way of looking at permutation, selecting and then making the arrangements. So from here we already know that NPR is equal to n factorial divided by n minus r factorial, right? So this we call equation 1. We also know now that NPR is same as NCR into r factorial, right? From 1 and 2 now it follows. So I'm just, because these two are equal, so this and this are also equal. So you have NCR into R factorial is same as n factorial divided by n minus R factorial, right? And now you can take R factorial in the denominator, and this will be the formula which we are looking for. This is what you have to remember now. Sorry, this block is just blocking this one, but I hope you get the point.